Our next lesson is about equivalent ratios. In this lesson, you will understand that equivalent ratios are obtained through multiplication, and you will find examples of equivalent ratios. Let's do the first example together. Find the number that makes the fractions equivalent. Remember, equivalent means equal or the same. 14/20 is equal to 7 over a missing denominator. Remember, we find equivalent fractions by either multiplying or dividing. In this case, the numerator goes from 14 to 7. It is getting smaller, so I know we must divide. 14 divided by 2 is 7. 20 divided by 2 is 10. Therefore, 14/20 is equivalent to 7/10. Go ahead and try B, C, and D on your whiteboard, and then check your answer. 56/35. If we look at the numerators, we can clearly see that they are getting smaller. 56 divided by 7 is 8. 35 divided by 7 is 5. So 56/35 is equivalent to 8/5. Now check your answer for the remaining two. 11/25. 44/100 is equivalent to 11/25. If you got this wrong, let's look. 100 divided by 4 is 25. 44 divided by 4 is 11. 27/45 is equivalent to 3/5. To get from 45 to 5, we divide by 9. 27 divided by 9 is 3/5. Next, they would like a denominator of 10. 5 times 2 is 10. 3 times 2 is 6. It is also equivalent to 6/10. I have a pancake recipe that calls for 6 cups of flour and 2 bananas. How many cups of flour do we need for 1 banana? We can clearly see from the picture that for each banana we require 3 cups of flour. However, we could also solve this with equivalent fractions or ratios. For example, 6 cups of flour and 2 bananas. 6 represents cups of flour, and 2 represents the number of bananas, B for bananas. We can find equivalent ratios in the same way we find equivalent fractions. It asks us to find the number of cups of flour for 1 banana. So, to go from 2 to 1, we divide by 2. 6 divided by 2 is 3. We have confirmed that we need 3 cups of flour for each banana. You have just found many equivalent fractions. 3 to 1 is equivalent to 6 to 2. You could also find that these are equivalent to 21 to 7, 18 to 6, and 9 to 3. If you have 9 cups of flour, how many bananas do you need? Let's start again. Remember, the order is important in ratios. If we consider flour first and bananas second, in the picture we can see that we have 3 cups of flour per 1 banana. We want to know how many bananas we will need if we have 9 cups of flour. Let's write a 9 here. Now think to yourself, what did you do to the 3 to get to 9? Remember, we're either multiplying or dividing. 3 times 3 is 9. Therefore, we will need 1 times 3, or 3 bananas, if we have 9 cups of flour. How many cups of flour would you need for 10 bananas? Let's go back to our original ratio, 3 to 1. Remember, that was 3 cups of flour for every banana. How many cups of flour will you need for 10 bananas? Bananas is our second number, so we'll write the 10 second. 1 times 10 is 10. 3 times 10 is 30. Therefore, we will need 30 cups of flour for 10 bananas. In this example, we compared numbers through multiplication. If we had said the recipe calls for 3 cups of flour and 1 banana, so it calls for 2 more cups of flour than the number of bananas, this would be comparing through addition. Let's try a new example. To find the missing part of this ratio, let's continue the sequence of equivalent ratios until 12 is the second number. Hint, you can use skip counting or multiplication. 1 going up to 2, we've multiplied by 2. 4 times 2 is 8. Increasing by 1 would be 12. 4 times 3 is 12. 1 times 3 is 12. Therefore, our missing number is 3. You could have more simply done this by looking at your second number. 4 times 3 is 12. Therefore, the first number must also be multiplied by 3. Find the missing term in the pair of equivalent ratios. We will do the first one together, and you can do the remaining 4 on your whiteboard. In this case, we're looking for the first number. Let's look at the second number, 5 and 20. What is done to 5 to get to 20? It is getting bigger, so we must have multiplied. 5 times 4 is 20. We must multiply by 4 to get the first number. 3 times 4 is 12. You try the next 4 and then check your answers. Pause the video now. There are many real-life examples of ratios. For example, how many seasons are in a year? Years to seasons. In 1 year, there are 12, I'm thinking of months. There are 4 seasons. In 2 years, we will cycle through 8 seasons. In 3 years, we will cycle through 12 seasons, and so on. Let's use equivalent ratios to solve this word problem. There are 2 red balloons for every pink balloon at a birthday party. For every 3 pink balloons. If there are 8 red balloons at the party, how many pink balloons are there? First of all, we know that there are 2 red balloons. I'll put an R for red. For 3 pink balloons. So, if there are 8 red balloons, how many pink balloons will there be? Let's look at the first number. 2 to 8. We must multiply because it's getting bigger. 2 times 4 is 8. Therefore, we must multiply 3 by 4, and we will find that there are 12 balloons if there are 8 red balloons. Our answer is 12. Please try page 117 and 118 in your Jump Math book.